Hello there. Hope you're doing well. This little video here will help you, will give you an example on graphing a couple of rational functions. We'll do two examples in this video. The first one we'll start off with is y equals 2x minus 1 over x plus 3. And if you remember our discussion in class today, one of the first things we want to do is to nail down where the vertical and horizontal asymptotes are. So the vertical asymptote of this function is in this case there is only one, it's the number that makes the denominator of the fraction equal 0, which would be negative 3. So we have a horizontal, excuse me, not a horizontal, we have a vertical asymptote at x equals negative 3. In this case, the denominator and the numerator have the same degree. So to find the horizontal asymptote, all we do is compare the leading coefficients. And that's 2 on top and 1 on the bottom. So that means that the horizontal asymptote is at y equals 2. So let's draw those in right now. So our vertical asymptote we'll put at negative 3. Let's see if I can do that here. That's not too bad. Let me move that over a little bit. Move that over to right about there. Okay. Then the horizontal asymptote at y equals 2. That's right about there. That's pretty good. Now, the next thing we want to look at, besides the asymptotes, is where the x and y intercepts are. If you think of the x-intercept as being the zeros of the polynomial in the numerator, the 0 of 2x minus 1 is positive 1/2. So we'll take and put a little mark there at positive 1/2 for the x-intercept. And then the y-intercept is where x equals 0. Substituting 0 in for x gives me a y-intercept of negative 1 over 3, so negative 1/3. So here are my x and y-intercepts right there. There's about negative 1/3. And we've got 1/2 marked. Now, that's really about all we need to do in this case. So I'm just going to draw a graph of the function here, and that's will be done. So it comes up along here, along these two asymptotes right there. And I know it does that because it crosses the x-axis and the y-axis at these points. Those are the only places where it crosses these axes, and so the other branch of this rational function is up here, symmetrical really, across those asymptotes with the branch that we just drew. So there's a picture of our graph, y equals 2x minus 1 over x plus 3. The next example we'll take a look at is the rational function y equals x minus 1 over x squared minus 2x minus 3. So a little different situation here. I still want to find the asymptotes and the x and y intercepts to begin with. And if I look at the denominator of this polynomial, this rational function here, the polynomial, if I was to factor that out, I'd have x minus 1 on the top. Can't really do anything with that. But the bottom factors out to x minus 3 times x plus 1. That means my vertical asymptotes then are at x equals 3 and x equals 1, or excuse me, negative 1. So there's my vertical asymptotes right there. So let me see if I can sketch those in here. X equals negative 1. There we go. That's not too bad. And then x equals 3. That's about right there. Okay. Now, if I look at the horizontal asymptotes for this function, I notice that the degree on top is less than the degree on the bottom. So whenever that happens, that means that the bottom of the fraction is growing much, much faster than the top of the fraction as x gets larger and larger. And so the horizontal asymptote for this graph is at y equals 0. That means the fraction itself, the value of this fraction, y in other words, is going towards 0 as x gets bigger and bigger. So that's kind of interesting there. I've got two vertical asymptotes, and the horizontal asymptote is y equals 0. Now, if I look at the intercepts for this graph, I'll notice a couple of things here. I see that if I'm looking for the x-intercept here. That's where y equals 0. I find the 0 of the polynomial in the numerator, x minus 1. That means that the x-intercept is positive 1. Now that's an interesting thing, because that means that my graph is actually crossing that horizontal asymptote. And that is okay. That is perfectly fine for a horizontal asymptote to be crossed at some point, maybe even more than one point. That's okay. The y-intercept of this graph I can find pretty easily just by letting x equal to 0. And if I put a 0 in there for x in the original function, I'm going to have negative 1 over negative 3, which is positive 1/3. So I'll mark that off right about there. Let me try that one more time. There we go. Well, one more time. There we go. So there's my x and y intercept. And the way this graph performs, if I go ahead and plot some more points, I will see that it goes right along like this in the middle. And the upper branch does this, and the lower branch does that. So this graph has 3 pieces. And there you go. There's a couple of rational functions there. The second one a little bit more complicated than the first. Bye-bye.